But for now, here's a circuit. So the circuit's really simple. We just have our potentiometer, the center pin connected to pin A0, and then one side at 5 volts, the other side at ground. So that's all there is to it, guys. Let's code. Okay, here we are in the IDE, and the first thing we want to do is create a variable for our pin number. So let's do that. Okay, so we wanted to use a byte to save space because it's just a pin number. And here we're also using the const qualifier, as good practice tells us to do so, because this is a global variable, and we wouldn't want some other part of the sketch to inadvertently change it. And remember, while we're using a potentiometer, in the real world, you'd probably use a sensor instead. The pot just simulates a sensor. So let's get into setup. We need to set up serial communication so we could see the output and the map function in action. So let's go ahead and do that. Okay, and that's really all we need to do in setup. Let's jump over to loop. So we need some kind of variable to store the reading we get from analog read and the potentiometer. And this time we can't use a byte because it could be anywhere from 0 to 1023. So we have to use an integer. So we're going to go ahead and do that next. Okay, and remember, we're using a pot for demonstration purposes only. But if this were a practical, useful circuit, we'd be using some sort of sensor, like maybe a light sensor or temperature sensor or something. Now we need to print it to the serial monitor. Okay, so now we want to map the range of values we'll get from the pot and analog read to a new range. And we're going to do 0 to 4, keeping with our fan example. And since we're only going up to 4, we're going to use a byte to save some memory space. And we need a variable, first of all, to store that map value in. So let's see what we're doing here. We set the byte mapped val to whatever the map function returns. And we could see for our arguments, we have the raw data from the pot, we see the old lows, and then the new highs. So our old range was from 0 to 1023 because that's the range of analog read. But our new range is from 0 to 4. And we could put whatever numbers we want in there, but we're going to stick with these for this lesson. Now let's print the new value to the serial monitor. Okay, so that looks like that should do it. Let's go ahead and upload this code and see what we get. And look at that. I forgot to use a quote in the beginning. How easy it is to make mistakes. There we go. And look at that, a typing error. I am not the best typist, but we're going to change that. And let's see. Hopefully we're not going to get any more errors here. Okay, now that we fixed my silly errors, everything seems to be working. Let's open the serial monitor. Drag it down here. And okay, so we see we're printing out. Now I'm going to go ahead and vary the potentiometer. And we can see the pot value going up. And this isn't a very good potentiometer, by the way. So we're all the way up to 1023. We're getting 4 back as expected. Now, let's see if I can dial in 1022. I had it a minute ago just to show you that indeed it's going to map to 3 and not 4. I think I could do it. Oh, I got close. And there we go. We have 1022, and we can see it maps to 3, and then 1023 is the only number indeed that maps to 4. So 1023 is the highest we're going to get that analog read is going to return, and then 4 is the highest of our new mapped value. Turn that off. And we're back down to 0, maps to 0 as we'd expect. And then we have 1, and then 4 again. So anyway, now you're a map function ninja, and we'll be using it soon in another lesson. Meanwhile, I'm sure you can think of other uses for it. Until next time, see you in the next lesson.